In this video, I'm going to show you how to draw a tangent line of this graph at this location A in Desmos. So let me just illustrate in Desmos. So we've got our sin x cos x. This is our graph here. And by the way, that's not the same as sin x graph. The sin x graph has an amplitude of 1. So so for any given point A, we can draw the tangent line. So our job is to come up with the equation of that tangent line. Okay, so let's jump back to this. So now, well, the equation of this tangent line, well, it's a straight line, so it's going to be of the form y equals mx plus c. So we need to know the gradient and the intercept. To work out the gradient, we would differentiate this. So notice that this thing here, this is a function of x, this is a function of x. So this is our u and this is our v. So we need to use the product rule to differentiate it. So whenever you want to differentiate one thing multiplying with another thing, you have to differentiate the first, leave the second alone, and then differentiate the second and leave the first alone. So so to follow this, differentiate the first. So remember, this is our u, this is our u, and this is our v. So differentiate the first. So when you differentiate the first, it will be cos of x. And leave the second alone. So leave the second alone. So cos x stays as cos x. And then you've got your plus, and then it's saying differentiate the second. When you differentiate the second, it will then be minus sine of x. And then leave the first alone. So leave the first alone. So leave the first alone. So when you differentiate two functions being multiplied with each other, it will then give you this whole thing here. So it's just a matter of tidying this up. So when you tidy this up, cos x times cos x, so that would be cos x squared. You got sine squared of x here. And so this thing here gives you the ability to work out the gradient anywhere along that graph. Anywhere along here, you have the ability to work out the gradient. But you want to know the gradient specifically at A. So what you do is, you put A into here. So you evaluate this gradient, you evaluate it at A. So this is a notation we would use, a straight line down with an A. So we're going to evaluate the gradient at A. And then the gradient at A will then be given by this. So this is just a symbol for working out the gradient at A. So you would put A into here and into here. That will then give us this. So the gradient at A is given by this. So we can put it into the M. That will then give us this. And then we've got our x plus c. So now we just need to work out the intercept. The intercept, we need to work out the intercept. The intercept is right here, but we don't know where this intercept is. It's right here, but we don't know where it is. So anyway, we've got the gradient. To work out the intercept, we need one specific point on that tangent line. Well, we know one point. We know this point here. Well, the coordinates at this point is given by a comma a sine a cos a, because if you want to know the height, then you would put a into here and into here, and then it will jump to the height. Well, anyway, the coordinates so this is your x coordinate, this is your y coordinate. So now we can put this into the y, put this into the x, and then work backwards to find c. So when you put this into the y, that will then give you this. Put a into the x, that will then give you this. Now we can work backwards to find c. So hang on. So now just multiply this out. This times this will then give you this. This times this, that will then give you this. So now add this block to both sides and then take away this block from both sides. That will then give you c. So you can now put c into this equation. So so the final equation for our tangent line is given by this. So you can just punch this into Desmos, which is this thing here. So this is the equation of our tangent line. And then as you slide A, it will work out the gradient and it will work out the intercept, and it will then draw your tangent line. Okay.